Okay, you guys, this video is about reactivity. Reactivity is how elements bond with each other, how they react to other elements. So if we look at our periodic table, you'll notice that at the very, very top that there are some numbers with letters. They go from 1 all the way to 8. This number lets us know how many valence electrons. So when you hear that word or you see that word valence electrons, you want to think reactivity. The more valence electrons I have, the less reactive I am. And the least valence electrons I have, the more reactive that I am. So this activity tells you to fill in the blank to identify the number of valence electrons for each group / family on the periodic table. So if you look here, it says group 1, how many valence electrons are in group 1. So this is letting us know that everything in group 1 has 1 valence electron. So it should correspond with 1. The next one is 2, so that should have 2 valence electrons. And then it skips over to 13. All you have to do is drop the 1. So group 13 or family 13 has 3 valence electrons. Group 14 has 4, 15, 5, 16, 6, 17, 7, 18, 8. Now, what does all this mean? Well, valence electrons tell you how, as I said before, how reactive that element is. So previously, when we taught this, or when you first learned it, we talked about happy atoms and sad atoms. Let's take a look at some. So here we have a sad atom. If you look at that red ring, there's only 2 valence electrons available on that ring. If you remember, we talked about the 288 rule. Each shell has a limit. So the first shell has a limit of 2, the next shell has a limit of 8. But that atom wants that shell to be full so it can be stable. And so if an atom does not have a full outer shell, it is considered unstable, which makes the atom unhappy. Here we have a happy atom. Why is it happy? Because that outer red shell is nice and full. Notice it has 8 valence electrons, which fills up its shell, making it absolutely happy. Let's go back to this sad atom. This sad atom would be considered a reactive element. Why is it reactive? Because other elements can come and fill up the shell. It has room for others to make this element stable. This happy atom doesn't have any room for anybody else. It's nice and happy all alone and by itself. It makes itself happy. In order for this sad element to be happy, it has to bond with other elements, meaning reactive. Next part of this sheet. Which atom below is the most reactive? Explain why. So let's take a look at atom A. As we just talked about, the atom, in order to be reactive or most reactive, it has to have the least amount of valence electrons. So let's look at each one, and we're looking for the element with the least amount of valence electrons. You should have chose atom A. Atom A is the most reactive because it has 1 valence electron that it needs to lose. So it wants to give that away. Which atom below is inert or non-reactive? And remember, non-reactive simply means my shell is full. I have no room for any other electrons on my outer shell. So one of these electrons has a full outer shell, meaning they have 8 valence electrons. Which atom is that? That atom is B, because it has 8 valence electrons, making it full and unable to bond. The last question. Of the elements NO, Cl, Na, and S, which two would likely have similar chemical properties and why? To have similar chemical properties, the elements must be in the same group, not period. Don't get those two confused. Remember, groups go up and down, and periods go left to right. So to have a similar chemical property, those elements must be in the same group. So look for each one of these elements and check out your periodic table to make sure or to name which one goes in the same group. Go ahead and pause so you can take some time to look at your periodic table. All right. So oxygen and sulfur have similar chemical properties because they are in the same group or family on the periodic table. So if you get one of those questions and they talk about similar property, or they may even say react the same. If they react the same or they have similar chemical properties, they are in the same group, which means they have the same amount of valence electrons. All right, you guys, go ahead and continue with your Nearpod.